Today we will be doing functions. Whenever we write an equation like this, y equal to fx, then this equation expresses y as a function of x. In this function, x is called the independent variable and y is called the dependent variable. When you graph a function, one very important thing to remember is that if you draw a vertical line anywhere on the graph, it should not intersect the graph at more than one point. For example, this graph is a correct graph of a function, whereas this graph does not represent a function, because you can see that the graph is intersecting the function at 3 places, whereas this one is intersecting at only one place. Now, whenever we have a function, the variable x has a set of allowable values. Those allowable values are called the domain. Now, if a function is given and you are told to find the domain, the first thing you have to ensure that if there is a fraction, the denominator cannot be 0. You cannot have a 0 denominator in a fraction. Second thing you have to remember is that you cannot have the square root of a negative number. Third is that if you have a function log x to the base a, then x and a both have to be positive and a should not be 1. In case of sin inverse x and cos inverse x, it is essential that x lies between -1 and +1. So these are 4 very, very important rules to determine the domain of a function. Now let us say that there are 2 functions. These are 2 functions, let us say. So if their domains are d1 and d2, then the domain of any linear combination will be the intersection of d1 and d2. So if you have 2 functions whose domains are d1 and d2, then the domain of the linear combination will be d1 intersection d2. Similarly, the domain of the product will also be d1 intersection d2, and the domain of the quotient will be d1 intersection d2 minus the zeros of this denominator function. The set of values of y is called the range of the function. To find the range, first thing you can do is express x in terms of y and then apply the same rules as for domain. The second is that whenever you have a function which involves a square root or a modulus, then you just try to find the range by observation, because square root and modulus functions, the range is best found by observing. if you have a function which is sine or cosine, then you can use this lies between -1 and +1. If you have a function x square minus x plus 1 by x square plus x plus 1, then you have to use quadratic formula. If you have a quadratic function ax square plus bx plus c, where a is positive, then the least value will be 4ac minus b square by 4a. And for ax square plus bx plus c, if a is negative, the greatest value will be 4ac minus b square by 4a. Now, the famous functions are modulus. Modulus is defined as x if x is greater than equal to 0, minus x if x is less than 0, and 0 if x is equal to 0. Then there is a function known as signum. So this is 1 if x is positive, minus 1 if x is negative, and 0 if x is 0 if x is equal to 0. Then the greatest integer function, which gives the greatest integer less than equal to x, and the Dirichlet function, which is given by fx equal to 1 if x is rational, and 0 if x is irrational. Now, what are odd and even functions? If fx and f minus x are always equal, it is called an even function. And if fx and f minus x are equal and opposite, it is called an odd function. Now suppose you have a function fx equal to x square. You can see that it is even and the graph is symmetrical about the y-axis. If you have a function fx equal to x cube, you can see that it is odd and graph is symmetrical about the origin. So this is regarding odd and even functions. Next we come to periodic functions. Suppose you have a function f of x plus k equal to fx, then the least positive constant for which f of x plus k equal to fx is called the period. So, for example, the period of sin x and cos x is 2 pi. In fact, the period of sec x and cosec x is also 2 pi. The period of tan and cot is pi. The period of x minus greatest integer x is 1. Now it's an interesting thing that a constant function has an indeterminate period because we cannot find the least positive constant. Whenever there are two trigonometric functions f and g, and let us say their periods are lambda and mu, then the period of afx plus bgx is the LCM of lambda and mu. Now we come to types of functions. This function is defined as one-to-one onto. Any one-to-one function is also called an injection. Any onto function is called a surjection. And a function which is both one-to-one onto is called a bijection. Have a look at this function. This one is definitely one-to-one, but it isn't onto. In fact, it is into. That means it is an injection but not a surjection. Now have a look at this one. This function is many to one and onto. And this function is many to one into. So these are the 4 different types of functions, and with this we come to an end of our first session of the chapter functions.